probability concepts. How many of you have studied probability earlier? All of you should raise hands because it used to be part of your school syllabus. So how many of you have the illusion that you've not studied probability earlier? Very good. How many of you are scared of probability? Good. So if you understand this topic well, this is going to be your favorite reading in the CFA syllabus. This is also going to be the reading where you would not be required to revise before the exams. So this is one of those readings again where either you know it or you don't know it. There is no in between per se. To me personally, it's a fun reading, and then if you really get hang of the things, then it gives you a lot of satisfaction to whenever you get the answer right, especially the slightly difficult ones. So the first learning outcome is on some basic terminology. So first term is random variable. Anything that's random is a random variable. For example, let us say if you have the cliche textbook example, if you throw a dice, a 6-sided dice, then you can either get a 1 or 2 or 3 or 4 or 5 or 6. So then getting one of those values would be a random variable. Are you following this? Or you people write your weekly examinations here. The score that you receive on those weekly tests, those are random variables. Or you invest into a stock and then you expect to earn some return in percentage. So the return that you would earn next year, that would be random variable. Then outcome, saying if you toss a coin, you would either get heads or tails. So getting either of the two would be a outcome. Fine. Event? Tossing the coin. Yes. So tossing the coin would be an event. Mutually exclusive. Select either one. So when you toss a coin, you would either get heads or tails. You won't get them together with one coin. And exhaustive. Exhaustive means heads or tails, two possible scenarios. There would not be a third one. Are you following this? So imagine writing CFA exams would be what? Writing CFA exams is an event. The result is random. Now today evening we have the exam results of the candidates from the previous batch, level 1, level 2. So whatever results that they get, which could either be pass or fail, then that would be a outcome. Mutually exclusive would be they will either pass or they would fail, or the results would be withheld. Cheating, if there are any those type of cases, then the results would be withheld. And mutually exclusive is that these are the possible events. So there could not be a fourth or fifth event in that scenario. Have you all read here? Two properties of probability. Probability of some event will always be between 0 and 1. So probability will always be between 0 and 1. So I'm sure you know this, but just at the risk of stating obvious, if you have a probability of 0.4, 0.4 is same as 40%. A probability of 0.55 is same as 55%. So 1 means probability of 100%. So we will not have a probability which is either less than 0, which is negative, or more than 100%. Second, if you have mutually exclusive events and they are also exhaustive, events, then summation of probability of each of the event has to be 100% or 1. Are we okay? So what does it mean? It means probability of attending this morning CFA level 1 session So let me call this as probability of attending classes is 40%, or probability of instead in the same time period going for a movie, how much? 60%. No, fine. So it's the probability of going for a movie is 20%. I mean, are the movie theaters open so early in the morning? Yes? Okay, sorry then. Another 40%. Fine. And then probability of sleeping. Sorry, I think we should correct them. 20%, 20%. How much? 60. Now I'm hoping that these are not, I'm hoping that these are exclusive events. I just hope that you don't sleep and attend the class at the same time. So hoping that these are mutually exclusive and exhaustive events, then the probability of all of them should be 100%. Are we okay here? Then next heading is, there are three types of probabilities: empirical, subjective, and priori. What would be an empirical probability? Based on historical observation. So one empirical probability that I have is, if you remember, we have discussed about the FAT examinations or FinTree assessment test. So this test we use to understand whether you should be writing the immediate CFA level 1 exams or the subsequent one. So in this test, there are two possible results, either a go or no. So empirically, all those candidates to whom we give a go in this test, we've observed about 85% candidates pass. Okay, but this is a historical observation, so that would be considered as a empirical probability. Subjective is that every time we decide to give go to someone, I personally feel that there is a 100% probability of the candidate passing. So that would be a subjective probability. So priori is formal inspection and reasoning. Okay, so a good example here is, if you throw a dice, then probability of having either 1 or 2 or 3 or 4 would be 1 by 6. So you're simply using logic here. So when you use reasoning, that would be considered as a priori probability. Will you be able to distinguish between the three? Empirical is based on historical data. Subjective is what you feel. So subjective is, chances of what? Chances of, let's say, landing up into an investment banking job. Okay. So if Mahavir thinks that the probability is 90%, then that is a subjective probability. But looking at Mahavir, if I use some reasoning and logic, and if I think that no, it's 95%, this is not a correct example, but if I use some mathematical logic, and then if I come up with a solution, then that would be a priori probability. Are we okay here? Next heading, odds for and odds against. So let's say I give you some data. Let us say probability of some event A, so typically written as PA, is 20%. So that event A could be anything. So what are the odds for the event? What are the odds against the event? So how I want you to think of this, now look at this carefully. When you get 20% probability, simply write this as 2 divided by 10. Can we? Now how do you interpret this? If you do that experiment 10 times, then 2 times you would be successful and 8 times you would not be successful. So when you have to find out what are the odds for, it will be 2 by 8. That if I do experiment 10 number of times, 2 times I am successful, 8 times I would not be successful. If you want to know what would be odds against, it would become 8 by 2, just an inverse of odds for. So given odds for or odds against, you should be able to convert that to probability. Given probability, you should be able to convert that to in terms of odds, either odds for or odds against. Okay, so write down this example. We'll practice a couple of them. Let us say probability of achieving the desired rate of return for an investor is 65%. Okay, so what would be the odds for and odds against? Odds for and odds against. Yes, odds for would be 65 by 35. Correct. So you can write this as 65% is same as 6.5 divided by 10. So if you do this experiment 10 times, 6.5 times you would have success, 3.5 times you would not have success. So 6.5 divided by 3.5 would be odds for, 3.5 divided by 6.5 would be odds against. Have you already? Let's do one more, this time the other way around. Let us assume odds against an event, odds against are 13 by 12. Find out what are the odds for and what is the probability of that event. So odds for has to be simply the inverted value, which is 12 by 13. So you have to take a total of these two values, which means you're doing experiment how many times? 25. Out of which 12 times you're successful, 13 times you're not successful. So probability of this event would be 12 divided by 25. Are you comfortable? Maybe last one. Okay, I'm going to go extremely slow in this topic, primarily because I've seen a lot of people have this phobia when it comes to probability topics. So we'll go slow so that you feel comfortable. Let's say probability of passing the exams. I'm hooked up with exam results today. So probability of passing the exams is 72%. Find out what are the odds for and odds against. So if you do this experiment 10 times, 7.2 times you would be successful, 2.8 times you would not be successful. So not that you have to write exams 10 times. So then your odds for would become 7.2 divided by 2.8 and 2.8 divided by 7.2. Yeah, it's okay to write 72. So that's the same thing. If you make this way, 72, 28, 28, 72, it gets you the same answers, the same values. Are we alright here?